Hello everyone, welcome to lesson number 3. Today we are going to talk about gases and some relationships between some variables in a gas. So we have 3 questions that we're looking to answer today. The first one is, what is the relationship between temperature and volume in a gas? What is the relationship between pressure and volume in a gas? And what is the relationship between temperature and pressure in a gas? So you're going to use a simulation today to figure this out. You will do a little bit of interactive inquiry kind of stuff to answer these questions. And then you'll come back and we'll kind of talk about it. Before you get into that, I want to just look at our vocabulary real quick. We saw these 3 variables, right? We're looking at the relationships between them in a gas, but let's define them. So pressure can be defined as the force exerted per unit area, right? So for example, gas particles inflating a balloon exert pressure on the walls of the balloon. So as you blow more and more gas into the balloon, that exerts more force on the walls, causing the balloon to expand, right? And pressure is defined as the force per unit area, right? So you could make an equation that's like P equals pressure equals the force divided by the area. The temperature is a measure of the average amount of energy of motion. So that's called kinetic energy in a system, and it indicates how hot or cold something is. So you've probably seen temperature measurements like this, 25 degrees Celsius or 0 degrees Celsius. We typically think about how hot or cold something is when we talk about temperature, but it really is a measurement of the average amount of motion energy that the particles have. So for example, water is a liquid at room temperature, 25 C, and a solid at 0 degrees C because it has less energy at this lower temperature. It has less energy the colder it gets, right? So more energy means higher temperature, less energy means lower temperature. And then volume is a measurement of how much space something takes up. And we've seen this one before, right? We've got some examples down here. So the first part of your assignment today is to make some predictions. In science, we make predictions based on what we know. This is an important part of being a scientist and doing science. You are going to draw in these boxes what you think 10 gas particles would look like if you could zoom in super close and actually see them. So you're going to draw 10 little particles. You can just use dots like this, and then you're going to draw arrows next to each of them to show their movement. Bigger arrows mean more velocity, or speed is another way to think about velocity. And the box is the container. So what do you think a low temperature will do to the speed, a high temperature? What do you think a high volume will do to the speed? What do you think a low volume will do? High pressure and low pressure. So that is the first thing you're gonna do on the worksheet that you have. So take a moment, pause the video and go ahead and do that. Now that you've done that, you are going to take a look at the simulation. So there's a link on the worksheet. You're going to click, or you're going to, I'll also link it on Manage Back so you can get into it. And it looks something like this. And I'm actually going to jump into the simulation here in a second and show you some of the things that you can do in it. And then you're going to work through that worksheet and you're going to discover the relationship between volume, temperature, and pressure in a gas. Okay, so when you get into the simulation, you'll start it and then you'll click on Ideal, right? You can see we have a container here. We have lots of different things to look at, right? We have this thermometer here to measure the temperature. Right now it's currently in Kelvin. You can also put it in degrees Celsius. We have a pressure meter. Right now it's reading 0 pressure, right? This is atmospheric pressure. We have two types of particles, heavy and light, right? You can add or subtract particles, so you can just plop them in just like that. You could add light particles, right? You can see kind of there's a difference there. And once you start adding those particles, you can, so I'll add a couple, decide to hold constant something. So like we could hold constant the volume. That means the amount of space will not change, right? Then we could observe the relationship between temperature and pressure, right? So when you're looking at the relationships between two things like temperature and pressure, we have to hold the third thing constant, right? We can only test the relationship between two things at a time. So keep that in mind as you're working through this worksheet. The instructions are pretty good. They tell you basically exactly what to do, but just keep that in mind. Down here we can add heat or we can take away heat, right? And that will help us determine some relationships. You can see your temperature up here. You can hold pressure constant or temperature constant. To change the pressure, you can, yeah, we're holding, oh, sorry, there we go. So now, right, temperature's constant, you can change the pressure. There's a lot of different things you can do. Make sure to just follow the instructions on your worksheet. It will kind of guide you through how to do this. And then at the very end of that worksheet, you're going to write what you think the relationships are between these variables. So good luck with that. When you're all done, you can come back to the video and I will describe some of the relationships. Good luck.